Hey Professor, how are you? Michael Petrullo here. I'm actually doing a video submission today. I feel like you got a bunch of papers, so hopefully this is a little bit more entertaining than just grading a paper. I wanted to get a little creative. But this is probably, I have a lot to say, so I'm gonna get into this quickly so this video doesn't go over 10 minutes. I'm gonna just jump right into it. And today we have a presentation titled Using Multi-Attribute Techniques to Solve Complex Problems. Alright. So, I would like to start off by introducing the multi-attribute work-related problem that I'm going to be talking about applying techniques towards. To be honest, I actually don't really have a job that requires me to take on multi-attribute problems. I normally just run a cash register as a cashier, very humble. I do recall one instance where I was working at a store titled Party City, and I had a surprise project thrown at me. The situation was as follows. My boss wanted me to take however many employees necessary and move a large number of supplies into a trailer by the end of my shift. This naturally brought up a slew of other requirements that I had to meet and fulfill, as well as forcing me to juggle multiple attributes in a short amount of time. There were 7 employees working that day, and I could not leave the store with less than 3 people, meaning I could only take 4 maximum people with me. The extra layer of this one portion of the problem adds a lot of potential variables, though. I was told by my manager to take as little help as possible, meaning if I can do it with 2 people, I only need to take 2 people. This store needs all the help they can get. So, knowing this, we can lay out the problem, a lot more in detail. I have about 4 hours to load a large number of supplies into a trailer. I have 4 people to pick from, but I'm highly advised to take less than 4 due to issues it may cause back at the store. If I brought 3 or 2, would there be enough employees with me? Would there be enough employees left to run the store if I brought too many? How can we get this done as fast and efficiently as possible? Would it be faster to make 2 trips with less people or make 1 trip with a lot of people? Which employee should I take? For example, employee number 1 might be a bad employee, but employee number 2 might be a good one. Employee number 2 will help me get the job done faster, but I can't leave employee number 1 behind. It would be bad for the store. So clearly this is a very layered problem with all kinds of variables that can change the outcome. As such, it would be best for me to apply the multi-attribute techniques that we have been taught to help us solve this complex issue so we can get the best outcome with minimal issues. The 2 techniques that I have chosen to apply to this problem are SMART and the analytic hierarchy process. So here's some source data that I compiled together. Both of these were the same for SMART and analytic hierarchy process, if I did this correctly. So I figured it'd be best to include them both here. And while we're here, also I'll say our objective, very specifically, our objective is to see if we can complete the work given to us as fast as possible by using the least amount of workers. So we want to get this job done as fast as possible while bringing the least amount of workers so that the store can be alright in the end. So I'll just get right into it. My SMART analysis went pretty much as followed. I know that SMART is more so used to determine single-layer problems, like the example that we were given in class specifically, where the man simply had to choose a new location for his store. I tried regardless and broke it down to multiple graphs and number points. We have the ones on this page earlier, our source data, and I also have the one shown right here. Oh, there's a mouse. Right here, as well as the graph. For this, I set an objective. The goal is to get the goal is to get the scores for both the store and for me to be as high as possible, but my score must be good enough for me to finish on time. I made that an arbitrary requirement of 40, 4 hours. Anyway, so I went through the process, step 1 being identify decision makers, that would be me. Step 2 being identify alternative courses of action, which we've done. Here you can see all the multiple different courses of action I could take. Identify the relevant attributes, which has been done. That being time, work ethic, and the amount of help a person can provide. Assess the performance of the alternatives on each attribute. We've done that also, right here. That's the whole point of the analysis. I don't want to get too much into the math and the specifics of it because I know this is not supposed to go over 10 minutes. But to make it simple, I basically discovered that taking 3 people allows me to finish while giving the store the highest possible value. If I took 2 people, I wouldn't be able to finish in time, and if I took 4 people, I would definitely be able to finish faster, but it's unnecessary. I could finish on time with 3 people. If we take a 4th person, what happens is the score of the store ends up getting lower than it needs to be. Since we're trying to keep the store at the maximum amount of workers, we're going to take 3 instead of 4. And you can see with the efficient frontier, it actually kind of reflects this in a way. You see that when we're at 2 workers, we are below the efficient frontier. We're just not going to be able to finish on time. Once we get to 3 workers, we see that we can finish on time, and the store has a good amount of workers. But you see as the graph goes on that the quality of work back at the store decreases the more people we take. And, despite the fact that this graph is going up, we're not on the efficient frontier, because once we hit that 4th person, we're at an unnecessary point for the store. The store starts going to a value that's too low, and we need to keep both of these as high as possible. So yeah, that's what the SMART analysis did. I think it was really useful. I think it could have been better, though, and I think it was reflected better when I did the analytic hierarchy process. I know that the analytical hierarchy process is very similar to SMART, but it's a little bit more loose. It focuses more so on making comparisons than calculating the weighted cost all at once. This made it easier for me to add an extra attribute to the mix, that being the employee work ethic chart. Choosing which employees to leave behind and man the store or go with me will heavily impact the efficiency of work with me and with the store. So I did a lot of calculations, obviously. I had to go through all possible combinations of taking all of these employees to see which one was going to work out the best. And I basically came to the conclusion that if I take employees 1, 6, and 7 with me, not only will the store have enough manpower to function well, but I also get to bring all 3 people. Even if they are not the best workers, according to the weighted score, they'd make more of an impact helping me rather than staying at the store, forcing me to take a better employee. I think that, if I have to compare the two, I think that SMART and analytical hierarchy process, I think that the analytical hierarchy process in this specific scenario was a lot better than SMART. SMART made its limitations pretty clear, especially when I had to incorporate it all into the graph. But the analytical hierarchy process I felt was a lot more free. It allowed me to compare the data directly instead of comparing the data all at the end through a weighted score. And I think that allowed me to, what that basically allowed me to do was add the employee ethic chart, and that allowed me to get both of the scores technically higher, but I allowed to get a much more, I was able to basically break the problem down and choose a much more logical path than just selecting random employees. Now I could pick which employees I want, and I'll have that impact the overall score at the end. And due to that, I was able to maximize my score and the party score, which is exactly what we were trying to do. It allowed me to add more variables, and thanks to that, I was able to properly figure out which employees would be best to take, which helped maximize both my number and the store's number. So, I think that covers everything. This should just be a regular video, but if not, I have a YouTube link posted. It's going to show up here. I just haven't put it here, and I'm going to put it in the comments as well, so you should be able to see it from 2 different things. Anyways, I wanted to say before I end, thank you for all the help during the semester, Professor. It's been rough, to say the least, learning all this online. I know teaching is not the best online either, but I think you've been more than forgiving with me doing the discussion assignments not exactly on time and all that, and I just wanted to say thank you for that. So hopefully this is a little bit easier to grade than a paper. Hopefully I hit all the bases. Anyway, thanks for the great semester, Professor. I appreciate all the help and the passes that you've given me. So I just wanted to thank you for that too. I hope you have a good day. Hold on, sorry.